Welcome everyone. Thank you for joining us for today's expert webinar titled Elastic Load Balancer. I am Ria from SpringPeople. We are India's largest enterprise training provider and I will be your moderator for today's session. In today's session, we have Mr. Pankaj Dube. Mr. Pankaj stands as a distinguished figure blending a wealth of hands-on experience with a passion for educating the next generation of cloud professionals. Boosting a stellar 5-year career as an AWS Cloud Engineer, Mr. Dube has seamlessly transitioned into a dynamic role, dedicating over 2 years of imparting invaluable is laser-focused expertise in AWS, including AWS organizations, SCP, VPC, RDS, IAM, EC2, S3, CloudTrail, SQS, SNS, and the versatile Terraform. Mr. Pankaj's commitment to staying at the forefront of technology is evident in his certification, holding the AWS Certified Cloud Practitioner and AWS Certified Solutions Architect Associate certifications attest to his foundational understanding and ability to design distributed systems on the AWS platform. In today's webinar, Pankaj will let us know about understanding elastic load balancing, ELB load balancer types, application load balancer, network load balancer, ELB load balancer components, ELB features. To all the participants, you can mention your questions in the chat box and it will be answered at the end of the session. Now, without further ado, let's start today's session. I would like to invite Mr. Pankaj to start the session. Over to you, Pankaj.
Thank you, Ria, for the introduction. Hello, everyone. Good evening. So, in today's webinar, we are going to discuss about the elastic load balancer. So, what's the agenda for today is we are going to discuss what is meant by load balancer, what are the types of elastic load balancer, what are the components of load balancer. We'll start with the application load balancer, the components in it. Is it internet facing or internal? What are listeners, the rules and conditions which we configure in the load balancer, followed by the target groups, health checks, and availability. So this is the agenda for today. So with that being said, so let's go ahead and discuss what is meant by load balancing. So first, what is meant by load balancing? So let's say you go to a coffee shop, you have a barista to serve your coffee. So here, if you see, you have two baristas and what it says unbalanced workload. So here one barista is serving the request for 3 customers and here is another barista who is serving the request for only one single customer. So that is the meaning of unbalanced workload. And when we talk about balanced workload, so there are 4 requests, couple of baristas. Each barista handles couple of requests, couple of customers. That is the balance workload. So AWS also offers elastic load balancer as a service. What it does, it distributes traffic across multiple resources. So what it does is it takes connections from the clients and distributes traffic across multiple backend servers. And your servers might be your application might be running on EC2 or they might be running on AWS Lambda. So takes the connection from clients and distributes evenly to the backend servers. So backend servers. So that is what a load balancer does. Okay, so resource can exist in multiple AZs. So let's say your EC2 instances are across in multiple AZs, multiple availability zone, let's say 1A and 1B and 1C. So load balancer will take care that it will evenly distribute traffic across the multiple availability zones. So that is the load balancer, ensures that no single EC2 instance has to carry fully workload on its own. And what also it does, it provides a single point of contact for your auto scaling group, for or your customers. Now I have already created a demo, and also we are going to see how to create a load balancer. So where I can find the load balancer on the management console, if I search here EC2, on the EC2, so EC2 Elastic Compute Cloud, where we create the virtual servers in the cloud. So I am here on the VC, already on the EC2, on the left hand side panel. Scroll down, and if you see here load balancer, so as of now I am in the Mumbai region. I have already created a load balancer. I have already created a load balancer, and load balancer is a regional service. So if you see, I have one load balancer created, and if you see the DNS name, this is the DNS name. How to check this? How this will route the traffic? We are going to check, but this is mean by it provides a single point of contact for your auto scaling group or for your customers. So that is the overview. So what are the types of elastic load balancer? So we have three types: application load balancer, network load balancer, gateway load balancer. Application load balancer works at or the operates at the application layer or the layer 7 of the OSI model. Layer 7, when we talk about layer 7, it is nothing but the HTTP and HTTPS. This is the application load balancer, ALB. When we talk about the network load balancer, it operates at the layer 4 of OSI model. So what protocol it supports? It supports TCP, UDP, TLS. Network load balancer. When should I use application load balancer? When should I use network load balancer? And when should I use the gateway load balancer? We are going to discuss. Okay, so that was about the types of load balancer. Now, what are the components of load balancer? What does a load balancer component? What gets created with the load balancer? So for components of load balancer, we have listener and we have the target groups. So this is the overview of the load balancer. Now let's go ahead and check. Let's go ahead and discuss what is meant by application load balancer. So as we discussed, application load balancer works or functions at layer 7 of the OSI model, layer 7 HTTP and HTTPS. So when you have an e-commerce web application, let's say you have an e-commerce web application and it runs on the protocol HTTP and HTTPS, use the application load balancer. So it can route different types of requests to hit different target groups using rules and conditions. We will discuss rules and conditions. Different rules can point to different target groups, and ALB can be used to load balance to containers. So it can be used along with the containers. It can be used with the Elastic Container Service. So different microservices running in different containers. Now let's take an example of a banking application. Let's say ICICI Bank. So you have features like a credit card, a debit card, or FD. So let's say there are more requests for credit card or more requests for debit card. So here is my application load balancer. It is going to check what if the request is received by once the request is received by the application load balancer, it will check what this request for. If it is for a credit card, this will move to the credit card servers. So it can be used with microservices. It also supports redirects from HTTP to HTTPS. Next is the internet facing and internal load balancer. So whenever we try to create an load balancer, so let's say if I click on load balancer, I have already an load balancer here. If I want to create a load balancer in another region, what I can do, I can just switch the region. So as of now, I have already a load balancer in Mumbai region. I'm not going to create the same in Mumbai region. Let me try to create in the North Virginia region. So load balancer, it's a regional service. Okay, I'm in the North Virginia region, EC2 console, EC2 dashboard, scroll down, and I can see here the load balancer. So if you see, I do not have any load balancer here. Now, if I click on create load balancer and application load balancer, so as you know, application load balancer, it works at the layer 7 of OSI model. Protocol it support is HTTP, HTTPS, use case, e-commerce web application, or any application that support HTTP and HTTPS protocol. So if I click on create, it says, it asks me for a name. Okay, we will name it, and it says me what is the scheme. So scheme can't be changed once the load balancer is created. So there are two schemes. What is that? Internet facing and the internal facing. Internal. So internet facing, when I have an application like an e-commerce web application, it should be internet facing. Now let's say I have an application. Let's say I work for ABC organization. I need to update my timesheet, I need to update my data and all these things. So this will be accessible within that. This application should be will be accessible within that VPC, within that network. In this case, I am going to use the internal facing. Okay, so internet facing and internal load balancer. So the internet facing load balancer has publicly resolvable DNS name. So, and the nodes will have public IP and private IP. So when I create an load balancer, when I create, let's say, an application load balancer across the subnets, so here I am, when I create a load balancer, I need to specify mappings. So select at least two availability zones. So let's say if I have selected US East 1A availability zone, 1B availability zone, 1C availability zone, and 1D availability zone. If I select these subnets, what it is going to do is one node will be deployed in each subnet. In each subnet, I have created an application load balancer with internet facing. Internet facing. So one node will be deployed in each subnet. Now here I have selected four subnets. I have selected four subnets. So one node will be in 1A, another node will be in 1B, second node I will call it as third node, where I will name it, it will be in 1C, and fourth will be in 1D. So fourth node will be in 1D availability zone, that is in the subnet. It is in the subnet. And these nodes, so elastic load balancer nodes will have a public IP and a private IP. These elastic load balancers will have a public IP and a private IP if the scheme is internet facing. Internet facing. Internet facing. So what is scheme? Here we have selected the scheme as internet facing. IP address type, select the type of address, IPv4. I'm going ahead with the IPv4. Network mapping, I have selected US East 1A, 1B, 1C, and 1D. So that is meaning by internet facing scheme. What is meant by internal? So internal DNS address not resolvable on the internet. Now if I just redirect to Mumbai region, I have already a load balancer. If I click on this demo ALB, what is the scheme? Here you are able to see is the internet facing. So what is internet facing? It has a publicly resolvable DNS name. So it can be resolved over the internet. So I can access it. So how to access that load balancer? If I so once I create a load balancer, it helps with the DNS name. So demo ALB is the name, hyphen AP hyphen south hyphen 1. This is the Mumbai region. This is the Mumbai region. Okay, let me click on it. I get a DNS name. If I copy the DNS name and I am trying to access this from internet, let's see what response I get. What says web server in Mumbai region AZ1B. If I try to refresh it again, it says web server in Mumbai region 1A. 1A, 1B. Now I am getting a response from EC2 instance in 1A and 1B. Now, how I am getting a response? Because I have launched EC2 instance, because these requests are served from the EC2 instances. So I have two EC2 instances and I have balanced the load across these two EC2 instances with the help of application load balancer. With the help of application load balancer. Now, what will happen if I create an internal facing load balancer? So DNS address not resolvable on the internet. And when should I use internal facing load balancer? To route traffic from web servers to the app servers or database servers. So if I create internet facing, that node in the subnet will have a public plus private IP. If I create, this is for internet facing. If I create internal, so the node in the subnet which will be deployed will have only private IP. Will have only private IP. So that is the scheme. That is about the schemes. Next is the listener. So what is listener? So it listens to incoming traffic on specific ports and forward request to the target groups. So what are mean by target groups? We are going to discuss. It listener analyzes the connection requests. So let's say I am hosting e-commerce web application, or let's take an example of Google. So Google offers gmail.com. It also help us to create the Google Meet, and also help us to to store the data, or that upload the data on the Google Drive. So let's say I am accessing gmail.com. The request will first come to application load balancer. It will check the request is for Gmail, and the request will be served by the servers which supports gmail.com. Another user trying to create a Google Meet invite, the request will be checked by application load balancer. It will be, let's say the meeting request is for Google Meet. The request will be sent to the servers which supports this Google Meet application. So that is the so this is how the listener works. So it listens to incoming traffic on specific ports and forward it to the target groups. And what is mean by target groups? So target groups consist of the EC2 instances, IP addresses, Lambda functions, on-premises server, or an application load balancer. Now, if you see, I am in the Mumbai region. And okay, I am in the Mumbai region. And if you see any target group, so I have created a target group with name any target group, and inside this I have two registered targets. And what are my target? These are my couple of EC2 instances, site 1 and site 2. So that's the reason. And this server, so web server in Mumbai region 1A and web server in Mumbai region 1B, these requests are run from the EC2 instances. So that is the meaning of target group. So what does a target group consist of? It consists of, so here if you see, I have three target groups. One of them is the any target group, and there are two targets registered within this target group, and the load balancer is routing traffic to this target group. So this is the work of a listener. So if your load balancer has no listener, it can't receive the traffic from the clients. So the rules that you define for your listeners determine how the load balancer routes request to the target. So that is the meaning of listener. Next is we have application load balancer rules and conditions. So the traffic is host-based routing or the path-based routing. So we have two types of routing. First is host-based, another we have is path-based, and here we specify the conditions. So what is meant by host-based? So route request based on the host name in the host header. So let's say if there is example.com target, I will send the traffic to the target group any. If the request is like test.example.com, this is another, let's say, another header, so the request will be sent to this test target group. So in short, what I'm trying to say is, so I discussed, like, you have Gmail, you have Google Meet, you have these kinds of application. So let's say for gmail.com you have 500 servers. For Google Meet, let's say we have 100 servers. Google Drive, we have, let's say, 1000 servers. 1000 servers. So if their request is for gmail.com, this request will be redirected to the target groups, and this target group, let's say I will name it as target group Gmail. So this request will go to the target group Gmail, because there are 500 servers which serves the request for the gmail.com application. Okay, so that is the host based routing. Another we have is the path-based routing. So route request based on the URL in the request. Now let's say if there is something called image or pics in the URL, I am going to send traffic to the different target groups, and rules are processed in the ascending order. So that is the rules, host-based routing and the path-based routing. So if I go to the Mumbai location, I have already a load balancer, as I shown you uh, the traffic is distributed across the nodes. So if I click on this one, and if you see listeners and rules, so what is a listener? It listens to the request. So what is a listener? It listens to the incoming traffic on specific ports and forward to the target groups. So if you see what is listener, so default action, it forwards the traffic to the target group. And what is the port configured? HTTP 80, as it is an application load balancer. What is the load balancer type? It is application. It works on HTTP and HTTPS. So here if you see, I have three rules. I have three roles. So first rule, site 1, second rule, site 2, and third is the default. So let's say by default the request served are web server in Mumbai region 1A and 1B. Now if there is a request, let's say something like site1.html, my request, if I try to access this link now, I get a response as a site 1. And if I try to access this one, site2.html, I get the response as site 2. So why this, how I can achieve this is possible with the help of the listeners. So what I have done, I have created a rule. What is the name of the rule? Site 1 priority is 10. And if I click on this site 1, what let me edit the rule. And if I click on edit the rule, what I have, what conditions I have specified is, if path, if any of the path has star as site 1, so the request should be redirected to, okay, so the request should be redirected to, forwarded to the target group site 1. And what is site 1 target group? So there are three target groups, so the request will go to the site 1. Okay, so this is how we create a rules and redirect the traffic across the EC2 instances. So about the listener, we have discussed host-based routing, we have discussed path-based routing. What are the target groups? Route request to individual register targets such as EC2 instance using the port. So what my target group consists of? If I click here, if I go to the target groups, if I click on the target groups, and if I want to create a target group, what can be my target? My target can be instances, my target can be IP addresses, even my target can be lambda functions or a application load balancer. So that is also possible. So how does a application load balancer works? So the load balancer will take the request from the clients, it will forward it to the nodes, and from nodes it will, so the listener is going to listen to the request on that particular port, and it is going to forward it to the target groups. Okay, so first what we need is to create a load balancer. We need EC2 instances. Next is we need to create a target group, and after that I need to create a application load balancer. Okay, so these are the three steps, and we are going to see a demo on how to create an application load balancer. So first I need EC2 instances, and I am going to create this. I am going to create the load balancer in North Virginia region. So for this, first I need EC2 instances, and where it should reside? It should reside in North Virginia region. Now, for this demo, to save the time, I have already created 4 EC2 instances. If you see the name tags 1A, 1B, 1C, and 1D, these are the instances which resides in availability zone 1A, 1B, 1C, and 1D respectively. And I am going to route the traffic to these 4 EC2 instances with the help of a load balancer. So my targets are ready. What I need to do, I need to create a target group. I need to create a target group. Okay, I need to create a target group. And what will be my targets? My targets are EC2 instances. If you see, my targets are EC2 instances. These are my targets. So choose a target type, instances. Target group name, let me name it as a web server. Target group, protocol HTTP, VPC, health check. What is meant by health check we'll discuss. And so if you see healthy threshold, unhealthy threshold, timeout, and interval, we are going to discuss. But let's first create the load balancer. So click on the targets. I want to register all these EC2 instances, all the 4 instances, include as pending below, and create a target group. So why did I create first target group is because whenever I'm going to create an application load balancer, it is going to ask me what will be the target group. So let's me go ahead to the load balancer. So here I'm in North Virginia. I am going to create a load balancer again. Which load balancer? Application load balancer, which supports HTTP and HTTPS protocol, layer 7. Create, and let me name it as a demo web server application load balancer. This is the name of the load balancer. Scheme, it should be internet facing because I am going to access the name from the internet. So it should be internet facing. IP address type, it should be IPv4, and I am going ahead with the default VPC. Now select about the mappings. Now if you see, my instances resides in 1A, 1B, 1C, and 1D. So I am going to select the same availability zone 1A, 1B, 1C, and 1D, and there is one subnet which resides in this availability zone. So that's the reason I have selected all the 4 availability zone. And what is meant by security groups? So security groups I am selecting as the web server security group. So if you go to the EC2 instance and if you click on the security group, and if I click on the web server security group, because I have selected the web server security group, click on this. So it says HTTP and HTTPS should be allowed from anywhere. So this should be anywhere. And the same security group I have used here. Okay, now listeners and routing. So as we discussed, listener listens to the request and it routes the traffic to the target group. So that's the reason I have created a target group. So if you remember, we already created a target group. Okay. If you remember, we already created a target groups. Do we have a target group? Yes, I am in the North Virginia. I'm in the North Virginia, and I have created a web server target group, and inside which I have 4 targets registered, which says health status is unused. As of now, I have not attached it with the load balancer. That's the reason it says unused. Okay, and what I am going to do, route this HTTP traffic to web server target group, to the target groups. Next is load balance tags if I want to attach, and AWS if I want to integrate it with the web application firewall for security. I can block the traffic at the edge locations, so I can block the traffic. So I can use this web application firewall where I can create web ACLs, specify the rules, managed AWS managed rules, or uh, customer rules, or any other third party rules I can specify here and I can attach, but not going to do for this demo. With the I can also integrate with the AWS Global Accelerator for performance, availability, and security. I'm not going ahead with that. Just going to create a. I'm just going to create a load balancer. Click on create a load balancer, and if you see, we have successfully created load balancer named Demo Web Server ALB. It is an application load balancer. Scheme is internet facing. Our instances resides in 1A, 1B, 1C, and 1D. That's the reason we selected 4 availability zone. This is the default VPC we used, and after creating a load balancer, it has given me the DNS name. And if I click check the status of it, it is in provisioning state. So this is how we create a load balancer. Once the state is active, we will try to see we'll try to access this and see if the load is routed to that particular targets. Okay, as of now it is in provisioning state. So this is how we create a load balancer. Now let's try to discuss about the health checks and availability. Now while creating a load balancer, or while creating a target groups, we got an option. So while creating a target groups, if you see, we got an option. What is that? Healthy threshold, unhealthy threshold, timeout, and interval. So let's try to discuss that. I'm not going to create a target, but just I'm trying to show it on the console what is meant by health checks and availability. So health check protocol, HTTP, and let's say my content resides in index.html. I will update here as index.html. So the load balancer is going to do health check of this index.html. Next is healthy threshold. So the number of consecutive health checks required before considering an unhealthy. So load balancer is going to do a health check of the EC2 instances, and if I specify here too, so once the load balancer has completed 2 successful health check, it will declare that EC2 instance as a healthy. What is the unhealthy threshold? If let's say the load balancer do a health check and it has observed that 2 consecutive health checks are 2 consecutive health checks have failed, the load balancer will not route the traffic to that to that particular EC2 instance. So timeout, the amount of time in seconds during which no response means a failed health check. So the EC application load balancer trying to do a health check and it waited for 5 seconds, no response, that means it is a failed health check. And what is the interval? If I specify here 10 seconds, so if you see healthy threshold, 2 consecutive health check. So there will be a first health check. After that, there will be a waiting period of 10 seconds. After 10 seconds, again there will be a second health check. Likewise, the interval between the health check is 10 seconds. Now, how much time? How much interval you want? 10 seconds, 5, you can configure it from 5 to 300 seconds. So I have specified here as 10. So this is the meaning of health check, how you can do a health check. Next is the cross zone load balancing. Before I go ahead and discuss cross zone load balancing, we already created an load balancer which was in North Virginia, and let's see if it is active. Yes, it is active. We did name it as demo web server ALB, and let's see if I can access with the help of this DNS name if I am able to route the traffic across my targets. Okay, what it says, I'm trying to access demo servers. This is the DNS name of the ALB. Requests are served from web servers in North Virginia from availability zone 1B. If I try to refresh, it says requests are served from availability zone 1C. If I try to refresh it again, it says request is served from 1D availability zone, and 1B, 1C, 1D. So my requests are distributed evenly across this EC2 instances. Now it has served request from 1A availability zone. And if I go to the North Virginia, I have 4 EC2 instances. If I click one of the instance ID, and if I try to copy the public ID, copy the public IP, if I try to paste here, it says requests are served from web servers in North Virginia. So likewise, I have 4 EC2 instance, and to route the traffic across these 4 instances, I have used the load balancer. I have used the application load balancer. So for individual, I do not want to use individual public IP address. That's the reason I have used this. I have used the load balancer. So this is the DNS name of my load balancer. Now if I go to the command prompt, and if I just try to do ns lookup, and I tried, let me copy the DNS name. Okay, ns lookup, and let me copy the DNS name, and if I try to enter, it says address 34.200, 34.228, 52.203, 34.201, and these are not your these are not your public IP addresses of your EC2 instance. So I have tried to do a NS lookup against this DNS name. It has responded me with this, and these are the public IP. These are the public IP of the nodes, of the load balancer nodes which got deployed in the subnets. Why it is showing me as 4? Because I have selected 1A, 1B, 1C, and 1D availability zone. I had 4 servers, and that's the reason it is showing me 4. Because in 1A, 1B, and 1C, one node got created, and each node, it has a public IP and a private IP. Why it has a public IP? Because our application load balancer is a internet facing. So that was about the load balancer. We discussed about the health checks. Now the cross zone load balancing. Now cross zone load balancing is disabled for network load. By default it is disabled for network load balancer. What is meant by cross zone load balancing? So let's say you have instances in 1A, and you have instances in 1B. In 1A, the node will be created. In 1B, the node will be created, and this node will distribute the traffic to the EC2 instance which resides in one availability zone. This node is going to distribute the traffic to 1B availability zone, or the EC2 instance which resides in 1B availability zone. So if I want this node, first node, to distribute the traffic to the EC2 instances in availability zone 1B, I am going to enable cross zone load balancing. So that is the importance of cross zone load balancing. So for network load balancer, it is disabled and it can be enabled. Okay, by default it is disabled for network load balancer, and transfer charges are involved. Next is cross zone load balancing is enabled for application load balancer. For application load balancer, we already have an application load balancer. And if I go to the target groups, and if I check the health checks, and if I click on the attributes, and if you say click on edit, and if I just scroll down, what is this cross zone load balancing? It's inherent settings from load balancer attributes, and it is on by default for the application load balancer. So that is the cross zone load balancing. Next is the sticky sessions. So when you can use the sticky session, or we also call it as the session affinity, which enables the load balancer to bind a user session to a specific instance. Now let's say I am trying to access e-commerce web application, and here I am, and my request goes to one of the EC2 instances. If sticky session is enabled, so the second time first time my request went to this EC2 instance. If sticky sessions are enabled on that particular target group, second time I try to access the same website, my request will be served from the same EC2 instance. So that is the meaning of sticky sessions. So user accessing the website second time, the request will be sent to same instance. So if I want to store the session data, I will use the sticky sessions. I can enable the sticky session from 1 second to 7 days. By default, it is 1 day. Next, what if this, let's say my request was here, and if this server fails again, the session data whatever it may be deleted, again my request will be sent to a new EC2 instances and a cookie will be generated. Okay, so every time sticky session is enabled, so stickiness generates a cookie which locks the device to the backend instances. Okay, a cookie will be generated. So that is about the sticky sessions. Deregistration delay. So what is mean by deregistration delay? It's, let's say you have four EC2 or let's say two EC2 instances, first and second. On this first instance, it has 10 requests. On its second instance, it has 11 requests. Now this instance is going to terminate as because there is less traffic. Now there are 10 requests on this EC2 instance which needs to be processed. So that I will call it as the in-flight request. And here I want this in-flight request to be completed successfully. So in this case, we configure this feature called deregistration delay. So what will so let's say if I configure the deregistration delay as 100 seconds, so load balancer will wait 100 seconds for this 10 requests to be completed successfully. Once these 10 requests are completed successfully, uh, completed successfully, then that EC2 instance will be terminated. So that is the deregistration delay. This enables the load balancer to complete in-flight requests made to the instances. Maximum value it can be set between 1 and 3600 seconds. Default is 300 seconds. Next is the routing algorithm. How does the with the help of this DNS name, I uh, tried to access my web server, and every time it says 1A or requests are served from 1A, or sometime it is served from 1B. How this happens is with the help of the algorithm. So AWS application load balancer is uses round robin algorithm. So the client request is sent to each server one by one based on the availability. So if I want to show you that, let's go to this one. Okay, I am into the target groups, web server target groups. Click on edit, and if you see, I can select first of all the deregistration delay. I can specify 10 seconds, and well, and I can also select the traffic configuration. Round robin algorithm by default. We also have the least outstanding request. Those instances which have lowest number of in progress tasks, the load balancer is going to send the request to that EC2 instance. So that is the these are the algorithms which application load balancer offers. By default, it is a round robin. If I want, I can change it for the particular target group. So network load balancer. So that was about the application load balancer, and when should I use network load balancer? It functions at the fourth layer of the OSI model. Fourth layer talks about the TCP, UDP, TLS protocol. And compared to application load balancer, network load balancer is faster And when should I use network load balancer? Those application which are non-HTTP or non-HTTPS. So example, a gaming server where you have designed a game and it runs on a custom protocol. You have financial applications or SMTP servers. In this case, you use the network load balancer. And the gateway load balancer, how it takes the traffic coming in and send it through a set of security appliances before it reaches the application servers. So let me show you the diagram. So let's say here you have a client. So the request first goes to the gateway load balancer endpoint. From endpoint, it goes to the gateway load balancer. From gateway load balancer, it goes to the security appliances. So security appliances are nothing but the firewall which are used to inspect the traffic. So once the traffic inspection happens here, the request is sent back to the gateway load balancer, back to the endpoint, and from endpoint your request reaches the application server. So instead of directly reaching it to application server, your request is first inspected with the help of security appliances, which are nothing but the firewall. And where you can find it, you can find it in the AWS marketplace. So let's say you in the EC2 console, you have AMI catalog. So where you can find trusted third-party AMIs. AMI is nothing but Amazon Machine Image, and here if I search a firewall, so these are the firewall which you can use: Fortinet, next generation firewall. All these products you can use to inspect the traffic. So that is the importance of the gateway load balancer. So last, the ELB features it. So application load balancer, network load balancer, gateway load balancer. It supports health checks. CloudWatch logs are logged in the CloudWatch. It supports logging. SSL offloading. So what is meant by SSL offloading? So SSL off. Let's say you have a client here. You have a client, and it sends the request to the application load balancer, and this application load balancer send it to the EC2 instance. So from client to application load balancer, the traffic is encrypted with the help of, that is the HTTPS, that is with the help of SSL certificate. And you have to attach the certificate with the help to the load balancer. And the service which helps to create the SSL certificate in AWS is the Amazon Certificate Manager. So from client to ALB, the traffic is encrypted, and from ALB to EC2, here the SSL connection is decrypted or terminated. And from ALB to the EC2, the request flows via the HTTP. So, and here the traffic is within the AWS network, backbone network. So that is nothing but the SSL offloading. From client to application load balancer, HTTPS. From application load balancer to EC2, traffic flows within the AWS network, and that is HTTP. Here it is in encrypted format. Here is in the plain text format. So that is the important feature of the uh, Elastic Load Balancer SSL offloading. We discussed connection draining, that is nothing but the deregistration delay. So we discussed about the deregistration delay. So deregistration delay and the connection draining is one and the same. So that was about the Elastic Load Balancer. To summarize what we discussed application load balancer, we discussed network load balancer, we discussed the gateway load balancer. Application load balancer works at layer 7, it works at layer 4, and this works at layer 3. It uses the GNV protocol, it uses TCP, TLS, or UDP, and application layer load balancer, HTTP and HTTPS. We discussed about the listener, the cross zone load balancing, deregistration delay. So how does the traffic flows? How does the traffic flows? First, from client, it will go to the application load balancer. From application load balancer, there are nodes. From nodes, it will go to the targets. So these are the targets. Okay, so that was about the elastic load balancer. And okay, so if you have any doubts, please let me know in the chat. I will be happy to answer that.
Thank you, Pankaj. Thank you, Pankaj, for your invaluable insights on technology. I'm sure it was certainly a very informative session for all of you. If you guys are interested in learning more about various AWS courses, do check out our super discounted batches of virtual instructor LED trainings on our website springpeople.com. These VILT trainings are leveraged online from the comforts of your home and flexible as per your schedule and location. If you do not have time to find any suitable batches, we'd be happy to discuss and schedule private batches for you. If you don't have time to join live online, then do try out our affordable self-paced courses. For more information, do write to us at training@springpeople.com or call on our number displayed on the current slide. Now we will open the forum to answer questions that we have received during the session. Over to you, Pankaj.
Yeah, if you have any questions, do let me know in the chat. Okay, yeah, I'm good. I do not see any questions here.
All right, thank you. Thank you, everyone. We appreciate you being here. We shall be sending out the webinar recording to all you participants soon. I request you to kindly provide feedback before signing off, which will help us improve the quality of our future events. Thanks again for joining us today. Signing off on behalf of Team Spring People. Hope to see you again for our next expert webinar. Thank you.